Hi. Okay. Hi. Welcome to the Pointer to. Oh, hold a moment. Hi. Welcome to the Pointer Topology Part 2 NPTEL course. This is Shavi, and I'm working up under Dr. Ms. Kosling at Mattress. So this is the eighth live session of this course. So still there will be a total four session left. Okay. So okay. So before starting further, let me know, do you have any question or any doubt? Um, Before starting further, please let me know. Do you have any question or any doubt? If yes, please let me know, or else we can we shall start with the assignment 7. Okay. Please let me know if you have any question or doubt. Okay, so it's okay. So where is that? Hold on. Whiteboard. I simply closed it. I'm extremely sorry for that. Okay. I by mistakenly I closed the whiteboard. Okay. Okay. So let's so okay, so let's start the problems. So the first question, no, okay, okay. So let's, okay. So let's start with the question number. Okay, so since you don't have any, you did not ask any questions, so start with um, start with what? Start with assignment one, assignment 7. Okay, start with assignment 7. So the first question is the following. Hold a moment, please. So, so the question is follows. Question one: give a topology tau on where on X which is not indiscrete such that F is equal to tau minus phi is a filter on X. So the what is the question? The question is that give a topology tau on X which is not indiscrete such that f equal to tau minus phi is a filter on X. Okay, that is what you need to prove. Okay, so So, I mean, see, the problem is not difficult. You need to only explore the definition of filter and try to figure this out, this problem. Okay, so there is really nothing to do extra. Okay, so take your time, please let me know. It is not a very difficult problem. Please take your time, let me know. Okay. The hint is that okay, so I must give some hint also. 1 minute, so everything working fine. Let me check. Okay, so I must give some hint also. The hint is basically you can exploit definitions of filters. Okay, that's what you can do by yourself. So take your time, please let me know. Okay. In the meantime, let me find some. Let me find some other questions too. Hmm. Okay. So the argument goes as follows. See, so the argument goes as follows. Okay. Hmm. So the solution is as follows. So so take X to be any infinite set and tau to be cofinite topology on X. Okay. Then F is a closed under finite intersection let A comma B be subsets of X such that A belongs to F and A subset of B. Okay, so in that case, now since A belongs to script F and A is equal to X minus S, of course, for some set S of X, and S is a finite set, it is important to keep a note of that. Okay, is a finite set of X. Then this will tell that capital B, which is nothing but complement of X in R, so this will hold for some subset R of S, which implies that B belongs to script F. Okay, so that is the argument. So the argument goes as follows. 1 minute. So we start with any x, which is an infinite set, and tau we are considering the cofinite topology on x. The point is that we are here considering the only cofinite topology. Okay. So one may ask whether can we consider co-countable topology or not. The answer is that we simply can't consider co-countable topology. The reason is quite obvious because in co-countable topology, things are not closed bounded. Okay. Now, then F is a closed under finite intersection. Now let A comma B be subsets of X such that A belongs to A subset of B. Since A belongs to F, A is equal to X minus for some S belongs to X, and B belongs to X minus for some S belongs to R. So this tells the argument. Okay, so that is the thing. Okay, now just hold a moment. Let me check if it's working fine or not. Okay, so now, so that is the first question. So please let me know, is this thing clear or not? So the next question is that give a set X. Hi Mustaq. So can you please confirm whether I'm audible and is the screen visible to you? Hi Mustaq, can you please confirm whether I'm audible and is the screen visible to you? Okay, there may be some network issue. Okay, so let's go back to our original question. Suppose we given a set X and two distinct filters, script F1 and script F2 on. Okay, Mustaq, thank you for the confirmation. On X says that both filter F1 is equal to A intersection. Thank you, Mustaq, for the confirmation again. A intersection B says that F belongs to F1, B belongs to F2, and F prime is equal to all this A union B says that A belongs to F1, B belongs to F2. These are filters on X. Just hold a moment, please. Okay. So this does what? So these are two filters on X. Okay. So basically, you need to find example of space X and distinct filters F1, F2. So their intersection and their unions are also filters on X. Okay. So this is also not very difficult. Okay. So think about it. Take your time. Let me know. It should not be difficult. So basically, you need to explain the definition of filters. Well, I hope everybody knows the definition of filter. There is nothing to explain. Take your time. Let me know. Okay. Okay. So the answer will be as follows. Okay. Hmm. Choose phi, not, I mean, of course, not be z, subset of b, subset of x, and a not equal to b. Okay. Take f suffix a and f suffix b be atomic filters with a and b respective atoms. So then check, then basically, then check that those hypotheses are satisfied. Okay, it should not be difficult to check. Okay, so that is the argument. Now the next question. So let X be a finite set and F be a filter on it. Show that there exists a net. Yes, from n to x such that F is equal to Fs, where F of S is the filter associated to the net S. So basically, you have some finite set and if we filter on X, we need to show that we can find a net yes from n to x with F is equal to atomic filter F of S. Okay. So yeah, so there is nothing too much difficult. I mean, just the point is that try to attempt the previous one. Hint is same. Try to do same process as previous problems. Okay. Take your time. Let me know. Hi Mustaq, please try and please let me know. Okay. In the meantime, let me find some other questions too. Please take your time. Please let me know. Okay. So, Mustafa able to solve it? Mustafa able to solve it? Please let me know. Okay. Seems not. So let me write in the solution here. So choose F to be B1, B2, BR. Okay. Now since F is closed under finite intersection B is equal to B1, BR, which in F. Okay. Now let capital B is equal to little b1, little b2, little b, and define yes from n to x by s of I is equal to s of k plus I is equal to bi for each. Okay. Now recall the f of s, the construction of this. Put s of a to be s of b, a less than equal to b, and let f of s is equal to a sub of x such that here exists a belongs to t such that s of s sub of b. Okay. Now since bi contains b and f of s is a filter, each bi belongs to s and so f sub of f of s. Conversely, conversely, if a belongs to f of s, that shall imply Sn sub of A for someone. But Sn equal to B. So B sub of A and F is a filter which implies A belongs to F. Okay. So the argument goes as follows. 1 minute. Oh shit. Again, I again closed my whiteboard. So, basically the argument is that we have established the capital F and capital closed and the finite intersection, okay? Where B to B1 intersection B2 intersection BR, okay? And B is equal to B1, B2, BR. And we are preparing S to be N to X, okay? That's what we're defining. Now, if you recall the definition of this in Sx, then we are defining subset S sub x with which contains all of the points SB such that A less than equal to B, okay? Since Bi contains B and f of S is a filter, each Bi belongs to f of S, and so f belongs to f of S. Conversely, if A belongs to f of S and Sn subset of f for some n, and if we put Sn equal to B1, so B is subset of A, and so f is a filter which implies A belongs to f. Okay, so that is the argument. Are this clear? Now go for the next question. Let X be an infinite set and X if be a cofinite filter on X and yes be a subbase of F. Then show that S is an infinite set. X is an infinite set and F be a cofinite filter on X. Show that F is an infinite set. Okay. Think about it. Take your time. Let me know. I shall be back in a few minutes. Okay. So, so in that case, okay, so the solution is goes as the answer goes as follows. Okay, so S be a finite set, x minus b1 daughter x minus b, where b1, b2, bn, these are finite subsets of x. Okay, now let b belongs to x minus b1 dot bn. Now x minus singleton b as in. Okay, so the thing is that let b belongs to x minus b1 b2. Now since x minus b as in, now x minus b as in f, but no intersection of elements of f will be subsets of x minus b. That means what? Status subset, yes. X minus b1 to x minus b, and b1 b to be a finite subset of f, and we are choosing b belongs to x minus b1 b to bn. Now x minus singleton b, it has no intersection of all elements of it. This will be a subset of x minus b. So yeah, so that is the thing. So I mean that is the argument. So there is nothing to explain more, I guess. That's So that's all for the assignment 7. If you have any doubt, please drop an email to me. I'll just go back to as soon as possible. Okay. So that's all for assignment 7. So now we shall move on some other assignments. Okay. In the meantime, if you have any doubt, please hmm, please unmute yourself and let me know. Now let's move from the subject objective assignment of this 7. Okay. So okay, so I shall wait for a few moments. Mustafa, if you have any doubt, please let me know. Okay. So, what is my pen? Okay. Question 1. We have filter on next. Then, tau F union phi is a topology. Hmm. Hello, I'm audible. Okay. Hmm. So, okay. Okay, so tau is equal to F unit identity is a topology. Next, so it is true or false? Take your time, think about it, let me know. It's never difficult. Anyways. So the answer X belongs to tau and tau is a closed under finite intersections and arbitrary. Is tau is a closed under finite intersection arbitrary union. So I mean that's obvious, so there is nothing to explain more, I guess. Now the question two. So of course it is. Of course the previous one is true. Okay, there is say no point. So obviously there is no point to mention. Now suppose if f1 and f2 these are two filters on X, then F is equal to A intersection B. A belongs to f1. On X. Mm, mm, If one filters on it, then F is a filter on X. Okay. So is it true or false? Think about it. Let me know. Take your time. Let me know. Okay. Mm. So, okay. So, it should not be difficult. The point is that some of you might get the answer is already false. Here is why. Okay. Take x is equal to AB, f1 is equal to ax, f2 is equal to bx, then phi is equal to second bracket is second bracket b. This belongs to f1 intersection f2. Okay. So that's why this is false. So there is nothing to explain more, I guess. Okay. 1 minute. Hmm. So that means what? So I mean, okay. So it nothing to do with that. Okay. So that's how it is false. So there is nothing to more explain, I guess. The third question. Third question, let X be a set having at least two elements. Okay. Now if B is a base for a filter F, then every element of F can be written as union of members of B. So the question is, I suppose X be a set having at least two elements. Now B be a base for filter F. Now show that every element of the filter community is a union of members of B. So one might guess that is true. So indeed that is not true. So try to find some examples which tells that this is a false. Okay, take your time. Let me know. So I'm writing down the answer. So it is false only. Okay. So you need to find the correct counter example for stating it's false. Okay. So the fun point is the answer is false. So the counter example will be take choose A B belongs to X and choose F to be singleton A comma X and basis B to be singleton A. Okay. Then clearly beta is a basis for the filtered F, but X cannot be written as a union of members in B. So that is the thing. Okay. So there is nothing to explain, I guess. Okay. So yeah, that's all. So the now the next question is next question is let X, sorry, what? Now let X be a set having at least three elements and let A B belongs to X. Okay. Then the filter generated by the subspaces X minus A B contains exactly four elements. So X be a set having the at least three element and A B belongs to X. Then the filter generates also X minus X minus B contains four elements. Okay, so true or false? Take your time, think about it, let me know. Okay. Okay, Mustaq, are you able to solve this? At least can you please unmute? So please let me know whether it's true or false at least. I mean, any idea, any possible guess or anything? Okay, so the filter generated by S is precisely x minus singleton A, x minus singleton B. Hmm. Hmm. So the filter generated by A is nothing but x minus A, x minus x minus x minus AB. So that's why. So that is true. Okay. So that's what is true. So there is nothing to explain more, I guess. Okay. The next question is, let X be a space and F be a filter. Next says that every cluster point is a limit point of F. Then F is the ultra filter. X is a space and F be F X be a space and F be a filter on X. Every cluster element. Then show that F. Then we need to show that F is the ultra filter. Okay. So it is true or false. Think about it. Let me know. It should not be difficult. So most of please try and please let me know. Please try to solve this yourself, Mustaq. Okay. So, so the point is the answer is false. Okay. Now choose x equal to yan and f be a cofinite filter on x. Okay. Now for any x belongs to x, we have nx e minus a union x is a finite set. Now since n of x subset of f, this tells f converges to x, and so f converges to every point of x. But 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 the prob but f is not an ultra filter on x, since sorry since neither the set of even numbers or the set of odd is an f. So that is the argument. Okay. So basically, we have some x, which if we choose a sort of natural numbers as a big space, and if it's a cofinite filter on x, then we are choosing x belongs to x and nx. But an nx belongs this tells f converges to x, so f converges to every point of x. Okay, but f is not an ultra filter of x. Now, since neither the set nor this is set of all numbers, so that is the argument. Okay, so Mustaq, is the argument clear? Please let me know. So if this is clear, then please go to the next question, namely, let x tau be a topological space which is not discrete. Then there exists a filter f on x such that every element of x is a cluster point f, and there exists a point in x which is not a which is not a limit point of f. So yeah, so it is true or false. Check it by yourself. Take your time. Let me know. I'll be back in a few minutes. So, so are you able to solve Mr. Mustaq? So first of all, the answer is true. Okay. Now how? So how it is true? Just hold a moment, please. Hello. Mm. Huh. So there is no audio issue. So yeah, so it is working fine now. Okay. So it is first of all it is true. Okay. So it is not sorry. I'm not. I'm extremely sorry. Is it true? I don't know. Sorry, it's true. Yeah, correct. It's true. True only. So first of all, choose F to be singleton X. Okay. So for all A belongs to U belongs to NA, but U does not belongs to F. Whereas U intersection X equal to U non-empty. Hmm. F equal to singleton for all A belongs to U belongs to N suffix A, but U does not belong to F. For U intersection X equal to U non-empty set. Okay. So this tells that the thing is true. Okay. So there is nothing to explain now. Okay. So that's all for this. So that's all for this assignment 7. So this assignment 7 objective, assignment 7 subjective, both are done. Okay. So if you have any doubt or any question, please let me know, or else we can move on the solving the other questions. Possibly assignment 6, I can remember. Well, assignment 6 has been done. That's good. So which question we can do? Uh, so there is some practice assignment. Let me check whether it is doable or not. Okay. Okay. So there is a practice assignment there is practice assignment too. So mm, let me do that. Okay. Okay, so there's a practice assignment eight. So before going to practice, let me figure out whether there are some other questions which can be done or not. Okay, so please wait. Let me check. Okay, okay, so that's okay. It is doing its work. Okay, so it is working fine. Okay, so before going to assignment eight, the practice assignment, let me questions. Okay, so first question is let x and y both second countable. X cross y second countable. Question is suppose x and y are both second countable. Now is x plus y second countable? So think about it, take your time, let me know. It is not difficult, it is actually easy. So this problem is HW, okay? Okay. Okay, so it is a HW problem. Think about it in home. Okay, so I'm not going to discuss this because this is a very easy thing to. There is no point of discussing. Okay, so now we are going to the next question. The question is, give an example of a separable metric space which is first countable, which is first countable, but not second countable. So question is that give you example of separable metric which is first countable but not second countable. Okay, take your time, think about it. Let me know. So Mustaf try to solve the question that is please try to figure out an example of a separate matrix which is first countable but not second countable. Okay, please try to attain at least. So please try to solve this. Hmm. See, see. So first of all, the point is that metric space is always first countable. Why? Because if we take any point x and we can consider collection neighbor b open neighborhoods around on bx 1 by n, okay? But it is not a, but it is also sometimes be second count, but also possibly second countable. So such a thing is not possible, okay? So that's why this question is, that's why it is the metric system, maybe the answer, okay? Okay. There is an interesting question. The question is that if if x satisfies second countability, if x satisfies second countability, then for all x belongs to x and an open neighborhood u of x, there exists a Clopen set v of x such that x belongs to v subset of u. Okay, that is the thing. X is second countable for all x belongs to x and an open neighbor u of there is a Clopen set v of x. X belongs to v subset. X belongs to v subset of u. Okay, so that is the thing. Hmm. So it is true or false. The question is true or false. Think about it. Let me know. So the point is that it is false. Why? Because the for all x, because for all x this property they are saying now. So this is, so this different, so this is zero dimensional space definition, correct? So this tells what this second countable implies zero dimensional, which is not true, which is not true anyway. Okay. So that's why this is down. Okay. So now, so the next question is as follows on it. Okay, there is one question. The question is that question is let x be zero dimensional. Show that Wx is also zero dimensional. X is zero dimensional, so that W of x is also zero dimensional. So by the way, what is the W of x? W of x was Wildman compactification. Okay, Waldman compactification. So of course you have seen this. So I am not going to explain that. Of course, I mean there is no point of explaining that. So it is true or false? Anyway, it is true. I'm writing this solution here. Okay. Point is x zero dimensional. Sorry, x 21 sphere. This means x has a basis b consisting of sets that are both open and closed. Now we need to show basically what Wx, the basis of Kloppen sets. Okay, that's what we need to show. Now we consider a Kloppen set B in X. Okay, let B restores all those F Wx as B belongs to F, where F is an ultra filter closed sets in X. Okay. Now consider closed set B in X. Okay. Let B upper star, of course. So, hmm. Now X minus B upper star is what? All those F belongs to W of X as X minus B belongs to F. Now an ultra filter F must contain either a set or its complement. Okay. So for the Clopen set, so for the Clop, so for the Clopen set B, so for the Clo, 1 minute. So for the Clopen set, so for the Clopen set B, every F belongs to Wx must contain either B or X minus B. This means what? This means Wx is equal to B upper X star minus X minus B upper star, and these two sets are disjoint. Okay. So this means what? That B upper star, that is Clopen in Wx. Okay. So this means what? The script B upper star, which contains all the B upper stars, so the B is Clopen in X, forms a basis for Wx. Now since Wx has bases consisting of Clopen sets, so this implies Wx zero dimension. Okay, so that is the thing. So yeah, so that is the argument. So yeah, so that is the argument. So that's all for today. If you have any doubt, please ask me, or if you have any doubt, please drop an email to me. I shall get back to you as soon as possible. Okay. And also one more thing I must mention is that if you, I mean, okay, so if you have any doubt from the previous assignment also, please drop an email. I shall get back to you, or please drop an question in that discussion forum. I shall get back to you as soon as possible. Okay. Okay. So I am leaving the session, and we shall meet on the next Friday. Thank you.